Okay, so today we're going to be talking about exponential equations and how to solve them. Now, when we're solving exponential equations, it's really not too tough, at least what we're going to be doing this year. The first key is to isolate the base. So that means like this number right here can't have any numbers adding or subtracting after it. Okay, so we need that number all by itself with its exponent. Most of these are already isolated today. Then we're going to write both sides of the equation with exponential expressions with like bases. That means that we need both of them to have the same base. So if this has a base of 5, then this needs to be a base of 5. So we need to figure out how to rewrite that. Once they have the same base, then I can drop the bases and set the exponents equal to each other and solve if I need to for the unknown. So look at this, my base is already isolated on this side. So now I just need to get this side to be a like base. So I need to get this to a base of 5 basically. So to do this, I'm going to see how many times 5 divides into it. So I'm going to do what I call the dividing tree to figure out how many times 5 goes into it. So I'm going to divide 125 by 5, and that gives me 25. And I'm going to keep going until I get to 5. So then I divide that by 5, and I get 5. Okay, now I look at how many 5s I have here. That is how many I need to put the exponent to. So I have 3 5s, so I can rewrite 125 as 5 to the third. So I know that 5 to the x is going to equal 5 to the third. And if you don't trust me, again, you can always check it on your calculator. 5 to the third power is in fact 125. Okay, so now I have them set up as like bases. Once I'm at that point, I can drop the bases because I know that the exponents would have to equal each other if the bases are the same, right? And my goal is to solve for x. So 5 to the x is equal to 5 to the third, then that means x has to equal 3 in order for those to be equal to each other. Okay, that's it. That's all I had to do. Let's look at another one. So this one, I'm trying to get this to a base of 2. Now I know this is a fraction, and we'll get to that. This is going to involve one of our fraction rules that we went, or not fraction rules, but exponent rules that we already talked about earlier. But let's start by just breaking this down to a similar base, to a like base. So we're going to see how many times 2 goes into 16. So divide 1 over 16 by 2, I get 8. Still not there. Divide by 2, I get 4. Still not there. Divide by 2, and I get 2. So 1, 2, 3, 4, I can write 1 or 16 as 2 to the 4th. So I can rewrite the equation. 2 to the v is equal to 1 over 2 to the 4th power. Now, in order to have a like base, I need this to go upstairs. Now remember, whenever we move numbers with exponents across the fraction bar, it changes the sign on the exponent, right? So if I move that 2 to the 4th upstairs, it's going to become 2 to the negative 4. It's the old man scenario, right? Doesn't like living upstairs. So then I have like bases now. I can drop the bases. V is going to equal negative 4. And that's my answer. And again, if you don't trust that, I can again prove it. 2 to the negative 4 is 1 over 16. Hey, how about that? Okay, let's look at another one. So this one is a little bit trickier, right? So this has a base of 5 and then 2r plus 4. That's all in the exponent. So I need to get this to a base of 5 as well. So I'm going to start by seeing how many times 5 goes into 25, which looks like it's just twice. So I can rewrite that as 5 to the 2r plus 4 is equal to 5 to the second power. They have like bases, so I can drop the bases, set the exponents equal to each other, and we're going to get 2r plus 4 is equal to 2. 2r plus 4 is equal to 2. Now it's a party problem, right? Best friend acquaintance, I'm going to get rid of the acquaintance first by minusing 4. Gives me 2r is equal to negative 2, divide by 2, and r is going to equal negative 1. That's my answer. Not too tough, right? Let's look at a couple more examples here. So let's look at this one right here. So again, we're trying to get 64 to a base of 4. So we're going to start by dividing by 4. 16 divided by 4, or 64 divided by 4 is 16, I believe, right? 4 divided by 4 is 16, yeah. And then still not there, so divide by 4 again, and get 4. So that is 3 4s, right? So I could rewrite 64 as 4 to the third. So 4 to the d is equal to 1 over 4 to the third. Still not quite a like base. I've got to move them upstairs, which means I need to change the sign on the exponent to a negative. So 4 to the d power is equal to 4 to the negative third power. And they have the like base now, so I can drop them, set the exponents equal to each other. D is equal to negative 3. Again, if you don't trust me that 4 to the negative 3 is the same as 1 over 64, you can plug it into your calculator, and hey, look, there it is. 4 to the negative 3 is 1 over 64. Okay, one last example. So looking at this one, I have negative 3 plus 3 to the t minus 1 power. Again, one of the first steps is to isolate the base, right? This base is not isolated. I have to get rid of this negative 3 before that base is isolated. So my very first step is going to be to add 3 to each side, which gives you 243 is equal to 3 to the t minus 1 power. Now this base is isolated, so now I'm trying to get this side to a base of 3. So I'm going to divide by 3 until I get to 3. So 243, this one's going to be a big one, is 81. Okay, divide that by 3, and you get 27. Divide that by 3, and you get 9. Divide that by 3, and you get 3. So let's count them up. 1, 2, 3, 4, 5 3s. So I could rewrite 243 as 5 to the third, or 3 to the fifth power. Sorry. Yeah, 5 3s. So 3 to the fifth power is equal to 3 to the t minus 1 power. Now they have like bases, which means the exponents must be equal to each other. So I drop the bases. 5 is equal to t minus 1, and then I just have to add 1, and t is going to equal 6. And that's my answer. Again, not too tough, right? I know dividing tree is kind of annoying to write out, but trust me, writing it out is much better than trying to keep it all in your calculator or whatever you try to do. If you have any questions, ask your teacher. We are here to help.